to my class. Today I am going to take you to the world of numbers. Now itself you understood this teacher is going to take mathematics, isn't it? Yes, dear children, your guess is correct. I am going to teach you chapter 1 rational numbers of class 8. So before saying about rational numbers, let us recall what we have studied in previous classes. So far, we have studied natural numbers, whole numbers, integers and fractions. So first of all, let me ask you, what are natural numbers? Can anyone say what are natural numbers? All the numbers that we start counting from 1 onwards are called natural numbers. Then we shall look what are whole numbers then. Anybody else can say what are whole numbers? When these natural numbers are along with 0, we call them as whole numbers. Remember, in natural numbers, 0 is not there, and in whole numbers, 0 is also included. Next, what we studied? Integers. Can anybody say what are integers? Yes, the collection of negative numbers, 0 and positive numbers are called integers. Next, we studied fractions. What is a fraction? Yes, fraction is a part of a whole. And also, we studied that a fraction have a numerator and a denominator. Can you say some examples of fractions? Yes, 1 by 2, 3 by 4, 2 by 5. Yes, okay. So, this 1 by 2, 3 by 4, 2 by 5 all have a numerator and a denominator. So, let us denote the numerator by the letter P and denominator by the letter Q. So now you said the examples of fractions as 1 by 2, 3 by 5, 3 by 4, etc. Look, these all have a numerator and a denominator. So it is of the form P by Q. Now we come to our topic, that is rational numbers. Rational numbers is only this much. Every number which can be expressed in the form P by Q, where this P and Q are integers. But remember, this Q must not be equal to 0, are called rational numbers. Once again, every number which can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0 are called rational numbers. Now are you confused? First teacher said P by Q is a fraction. Now teacher is saying P by Q is a rational number. Yes, children. P by Q is a fraction and also a rational number. And look, this P by Q can be a positive number or a negative number. Again, are you thinking, is 6 a rational number? Is negative 2 a rational number? Is 0 a rational number? Yes, dear children, 6 is a rational number. Why? Because we can write 6 in the form 6 by 1. And this negative 2 can be written as negative 2 by 1. 0 also can be written as 0 by 1. These all are of the form P by Q. So, these 6, negative 2 and 0 all are rational numbers. So, what can we say? All integers are also rationals. So, once again, the definition of rational number is every numbers which can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0 are called rational numbers. Why I said Q is not equal to 0, do you know? Because we have studied division of a number by 0 is not defined. That is why we are saying Q must not be equal to 0. So we will move to the properties of rational numbers. We have studied the properties of whole numbers and integers in previous classes. Similarly, rational numbers also have some properties. The first property is closure property. What does this closure property says? Closure property for addition we can check first. That is, if we have two rational numbers a by b and c by d, if we are adding these two rational numbers, the answer that is getting must be also a rational number. Let us check with an example. First of all, let us check an example using same denominator. 2 by 5 plus 3 by 5. Same denominator, like fractions addition, you have studied in previous classes. So here, it is 5 in the denominator, 2 plus 3, the answer is 5. And this 5 by 5 is 1. So 1 is a rational number. Next, we can check using another example having different denominator, that is unlike fractions. 2 by 7 plus 1 by 2. Here 7 and 2 are the denominators, different denominators, so we must find the LCM and add. So the LCM of 7 and 2 is 40. So here the answer will come as 2 by 7 into 2 into 2 plus 1 by 2 into 7 into 7. So the answer is 4 by 40 plus 7 by 40. Now it is same denominator. Then denominator come here 14. 4 plus 7, it is 11. So 11 by 14 is a rational number. So now we saw that addition of rational numbers. So the answer is 11 by 14 and it is a rational number. So in these two cases, we saw that closure property is satisfied. Now we can check for subtraction. Subtraction, in the case of subtraction, we must check if a by b is a rational number and c by d is a rational number. If we are subtracting these two rational numbers, the answer that is getting is also a rational number or not, we can check. So first let us take two rational numbers having same denominator. 5 by 7 minus 2 by 7. 5 by 7 is a rational number, 2 by 7 is a rational number. What is the answer? 5 minus 2, it is 3 by 7. So this is also a rational number. So here closure property satisfies. Next check using another example. We can check 7 by 9 minus 2 by 5. Here look, different denominator. So must check find the LCM. 9 and 4's LCM is 45. So make the denominator same. 7 by 9. 9 into 5 is 45 into 5 minus 2 by 5 into 9 into 9. So here it is 35 by 45 minus 18 by 45. So what is the answer? Denominator is 45. 35 minus 18. It is 17. So 17 by 45 is also a rational number. So in these two cases, we saw that subtraction for rational numbers is closed. Next, we can check for multiplication. How to check for multiplication? If we have two rational numbers, a by b and c by d, multiply that rational numbers a by b and c by d, then the answer that we are getting must be also a rational number or not. Let us check. So let us take some example. 2 by 5, a rational number, into 3 by 4. Multiply this and look. Multiply the numerator. 2 into 3, it is 6. And 5 into 4, it is 20. Here 6 by 20 is a rational number. So here closure property satisfies. The case of division. If a by b is a rational number and c by d is a rational number, we can divide these two rational numbers and check whether the answer that we are getting is also a rational number or not. So here we must check a by b divided by c by d is a rational number or not. Take some examples. Let us take 7 by 9 divided by 2 by 5. We have studied the division of fraction in previous classes. Same itself here. 7 by 9. This division will become multiplication, and take the reciprocal of 2 by 5. It is 5 by 2. What's the answer? 7 into 5, it is 35. And 9 into 2, it is 18. Here closure property satisfies. Next, we can check with another example. Take on a rational number 2 by 3. And you have studied that 0 is a rational number, right? So, divided by 0. Is it possible? We have studied division by 0 is not defined. So, in this case, if c by d is 0, we cannot divide. So, in the case of 0, this division for rational numbers is not possible. So, we can say closure property does not satisfy for division. So, now we discussed the closure property for addition, subtraction, multiplication and division. And we saw that closure property satisfies only for addition, multiplication and subtraction, and does not satisfy for division.